Alright, welcome back to the third installment here of the very brief introduction to video game design here, doing a platformer game. We're gonna start off here. We're gonna cover a couple of interesting things here. We're gonna talk about how to make it so that our player has a health component, so that our enemies will actually deal damage to us. Talk about how to make it so that our enemies are more easily duplicated, and to make it so that our enemies will actually pace back and forth. So that behavior that we see in Mario, where the Goomba will walk back and forth, that sort of thing, as well as some other aesthetic things that we can do. So getting like a parallax background and that sort of thing. So before we actually get into the health and the enemy movement and that sort of thing, I want to talk about just some of the things that we can do to make our level look a little bit better. So one thing that I've done here is I've changed the camera color. So if we select the main camera, you can change the background color to be sort of a sky blue. We see in the camera preview here that that's the color that it will fill the background with. So that's pretty nice. We can change that. Another thing that we want to do is on our ground tile map, we want to add a couple of other components here. We see last time we just added the tile map collider to our tile map, and that makes it so that every tile of our tile map has its own collider, which is good because then we can actually land on our tile map, but sort of a problem because we can catch the corners of our tiles if we're walking along it. So what we want to do instead is we want to, in addition, is we want to add this component. Let me get it so that it's all back how it was. So this is what it will be like before. It has all the different individual colliders. We're going to add a composite collider. So that's composite collider 2D. This is a component that's actually going to combine each of these colliders into one big collider, which is really nice. Now, when we do that, we see that it also comes along with a rigid body 2D component. We don't really want to have that on it, but it's necessary for the composite collider to work. If we just push play as we do this, we see that our ground will fall out from under us and it'll continue moving, which is not really good. So what we can do is we can go onto the rigid body and we just change it from dynamic to static. So we just say it's going to stay put. It's not going to move around. We just want it to stay put. So we have the composite collider there. We need to, on the tile map collider component, we need to say used by composite. So we need to check that little box right there, and then bingo, all of our colliders will be combined into one singular collider, which is really nice. We don't have each individual line here. That's very nice. Another thing that we want to do, we noticed that we were able to stick to the sides of walls, which is not very good. We're going to add another component that's the platform effector 2D. And so what this allows you to do just by default is use one-way collision. We don't really want to do that, so we're going to uncheck use one-way. But if we look at the other section here that says sides, it has the ability to use side friction or side bounce. So we can tell it to not use side friction, leave this unchecked, and then we will slide on the side of these platforms, which is the expected behavior that we expect to get. So that's pretty nice being able to do that. Now if we play it, we should be able to, if we jump on to the side of our platform. Oh, right. It doesn't work because we haven't told our composite collider to be used by that effector. So we kind of have to build this daisy chain where we say the tile map collider, this is used by the composite, then on the composite we say this is used by the effector. So the effector will affect the composite collider, so the big collider, and then we'll just slide off the sides because we're not telling it to use side friction. One way is basically being able to jump through platforms, which is good for sort of floating platforms, but not for ground. So if you want to be able to jump through floating platforms, you can do that, but I encourage you to create a different tile map for that, because on this one you can sort of, using one way makes it so you can like sometimes you can jump through these platforms this way, which is not very good. So we don't want to be able to do that. Okay. So the last thing that I'm going to show you before we actually get into the scripting part here is how to change our camera so that we can have what's called a sort of parallax background. What that means is that things that are further away from the camera move more slowly. This is how things work in real life, right? If you move side to side, you know, the mountain range way off in the distance, to your perception, doesn't seem to move that much, but the computer screen right in front of you moves a lot, right? So that's what we're going to do, and we're going to do that on the camera. We're going to change the projection mode from orthographic, which is the default for 2D projects, to perspective. That means that it is going to be relative to, the movement of objects is going to be relative to your perspective, to, you know, how far things are away from the player. So I have this background tile map here that we'll see it has a different Z position, and as I move side to side, we see that it moves more slowly relative to the player's position. This is because on the background tile map, I've set the Z position to be 2, positive 2 on the Z. That means, remember, positive Z is going into the screen, so it's further behind the tile map that we have here. Negative Z is sticking out of the screen. That is where the camera lives, right? Our camera is living at Z of -10. Player is at 0, so that means that the camera is sticking out of the screen at -10. The other tile map is at Z of positive 2, so that means that it is 2 units behind the player. Now watch what happens when I change this 2 to 20. It looks way smaller, right? And they move way more slowly. This makes a lot of sense when we think about it. The mountains, going back to that example that I gave before, the mountains way off in the distance look really small, right? When you're, you know, standing on the other side of town, mountains are you know, hour and a half drive away. They are really small to your perspective. So when we push these things further away from us, so Z of 20 is actually 30 units away from the camera, it looks much smaller. If I only want it to move a little bit more or a little bit less, then I shrink that number down, so it's just a Z of 2 like I had before, and we see that it has a less drastic effect on the movement, which is pretty nice. Okay. Another thing that you might want to be aware of on these things is the ordering of them. The way that they are rendered could matter. So lower numbers in the order and layer on the renderer will be rendered first. Higher numbers will be rendered later. So that means that I've set this order and layer to be -1 on this thing because I want it to be behind the ground, which has the order and layer of 0. So it'll go -1 will happen first. It's like a painting, right? You paint the background first, and then you paint the stuff that's in front of it. So -1 happens before 1. So that's the order and layer, the way that that works. It's not just based on the Z. Okay. Now let's talk about enemies. Let's talk about creating something that will move around and hit us and cause us to take damage. Okay, so we're going to create an enemy here. I'm just going to create a 2D sprite. I'm going to set it to be the default circle. Make it be slightly bigger. Move it over here, and I'm going to make it yellow. Sure. Okay. Maybe like a magenta. Okay. So we want to add I'm going to add a circle collider to this thing. And we want to add a rigid body. But the thing about this rigid body is, you know, if we think about Goombas, typically Goombas are not, you know, walking and falling down into the holes, right? They just pace back and forth. So the way that we can sort of write code that'll make it so that we'll be able to have Goombas and enemies that will fly up and down or diagonal is by just coming in here and setting our gravity to be 0. If we set our gravity to 0, yeah, sure, our enemy won't fall, but usually they don't want them to fall anyways, right? We just want to place them so that they look like they're walking on the ground, and then we just have them move back and forth, and whether or not they have gravity doesn't matter, right? So we can set their gravity to 0, and then if we just code them so that they move back and forth, then we can do that. Okay. So I'm going to name this enemy. Okay. And now we can get into the scripting. So we're going to create a C# script. I'm going to call this enemy move. Okay. My enemy move script. And from here, we're going to start to program their behavior. Okay. So we need to have a couple of different types of variables for the creation of the script. The first thing that we need is to have a direction. So we need to get a velocity for our enemies to pace in. So we are going to create a public variable at the top of the class here. We're going to say public. And if you recall from last time, variables like position use a special kind of variable. So this is 3 different floats lumped together. We also get something similar for that for velocity, where it's 2 different floats that are lumped together. And those are called vectors. So we're going to create a variable here that's called a vector2. So we're going to create a public vector2, and we're going to call this pace direction. Okay. Then we are also going to create a variable here that's going to be a public float. Remember, floats are decimal values, so we want to have sort of more control over this variable. This is going to be our move speed. I'm going to default set it to 3, and I'm going to create another float that is going to be our walk timer. Walk timer. And it's going to be equal to 2. So this is going to be the amount of time that it walks in a direction before it switches directions. So it'll walk for 2 seconds, then switch directions, go the other way. Okay. The code for this is really pretty simple. Oh, we actually need one more variable here. It's going to be a float timer. It's going to start at 0. It doesn't need to be public because we don't need to see it in the inspector. All of the value for timer is going to come from the code here. Okay, and all of our code is going to go inside the update function. Remember that function runs once per frame, so it'll run about 60 times a second. And what we are going to do in here is we are going to influence our timer. So there's a couple of different ways that we can do this, but we're going to basically, if we think about update is a function that is run every single frame of the game. And what we can actually do is there's a variable in Unity that will tell us how much time has passed since the last update function was run. So it'll say, there's been 1/100th of a second that has passed since the last update function was run. So what we can actually do is we can add up all those little slivers of time. So we're going to say timer plus equals, so we're going to add a value to timer. So we're going to timer plus equals time.delta time. And what this is saying is, hey timer, whatever your original value was, whatever your last value was, add time.delta time to it. Delta in math being the change in time, meaning the change in between the real time in between updates. So how much time has passed in between these update function calls, add it to our timer. So after 6 seconds, our timer value here should be 6. Okay. Then we're going to do an if statement. We're going to say if our timer is greater than our walk timer. Remember, if statements don't end in semicolons, they have their own encapsulation with the curly braces here. If our timer is greater than our walk timer, then we're going to say our pace direction equals negative pace direction. Flip it. Okay. Whatever it was before, it's now negative. So if we were walking in the negative x direction before, now we are walking in the positive x direction, and vice versa. Okay. Then we need to reset our timer. If we don't reset our timer right here, then our pace direction is just gonna, every single frame it's gonna flip. So it's just gonna be twitching side to side, side to side, side to side, which is not good. So we need to reset our timer. Then the last thing we have to do, get component rigid body 2D dot velocity, and I'm kind of going through this quick because this is similar to what we did last time. So we're going to get the rigid body 2D component, and we're going to modify its velocity to be equal to pace direction times our move speed. What direction are we going in? How fast do we want to be moving in that direction? Okay. Now, one more line of code that we want to add in here, and that is to make it so that our pace direction is always the same magnitude. So if we think about if we were wanting to walk in a horizontal direction here, then we would say, well, I want to walk in positive 1x and positive 1y, right? Well, that vector, that pace direction vector, would be longer than just positive x. Okay, so we want to shrink it down so it always has the same length. So we're in start. In the start function, we're going to say whatever our pace direction is, we're going to normalize it, which basically means however long it is, shrink it so it only has a length of 1. So this is just used for direction, not for how fast it moves. Okay. So we can save that, switch back to our project, select our enemy, attach our enemy pace script to them, give them a pace direction, and if we push play, we should be able to observe our enemy pacing back and forth. Now you just want to be sure that when you are placing your enemies, that you're placing them in a position where they can actually move, and you don't have like this overlap like I have where they're pushing over the side. Okay. Now that's a problem. I can move them around. Right? So I can move them around right now without any sort of consequences. There's no bad stuff that happens from me touching the enemies, right? That's not good. Also, right now I'm only able to have one enemy, which is also not good. What we need to do is we need to think about the concept of enemies, because if I duplicate an enemy here, these have different names in the hierarchy. One of them is enemy and the other one is enemy 1, right? So even though they're, technically we think of them as being enemies, they are completely different names, right? So what we want is a way of sort of bundling these together so that they are all sort of identified the same. We can use that by using the tag system. So see, in the inspector, there is a tag dropdown. Last time we used the layer dropdown for being able to jump. Here we're going to use tags, and we're going to add a tag, if you don't already have one, called enemy. So we can tag our enemies as enemy. Then we can, in the code, we can check to see if we run into anything that is tagged as enemy to deal damage to us. Okay, so that's what we're going to do. We're going to create a new C# script. We're going to call this player health. There we go. And we're going to create a couple of public variables at the top here. We're going to create a public int this time. No, int. And we're going to call this HP. I'm going to start it at 10. And I think that is actually all that I really need. However, we're not going to do the code in start or in update. We're going to create a new function down here because if we think about the way that we handled groundedness when in our player, we also said if they run into, that was a collision function, on collision enter, If we start a collision with something on the ground layer, then we are grounded. Well, here we're going to do a very similar thing. So we're going to say on collision enter 2D. If we start a collision, we're going to say if the collision game object tag equals enemy. Now remember, we use a double equal sign here for comparison. If we use a single equal sign, then it's trying to change the value like we did up here, where we change the value of HP to be equal to 10. We set it. Down here, we need to do two equal signs because this is doing a comparison. We want to compare the tag of our enemy to this string. Okay, and if those strings are the same, if they are equal, then we want to run the code in our if statement. In here, we want to say HP minus minus. We want to reduce health by 1, HP minus minus, that's what that does. It says whatever the value you had before, if you were 10, you now become 9. Then we're going to do another little bit of tricky code. But in order to do that, we actually need to come up to the top of the script. We need to say using Unity Engine dot scene management. Okay. So using scene management allows us to influence what scene we're on. So we're going to come down into our script here, and we're going to tell the scene manager to load a scene. And then we're just going to ask the scene manager get active scene. You can do this multiple ways. You can do name or you can do build index. Either one works. You can load scenes based on name or build index. So we're going to say scene manager, I want you to load a scene. It says okay, what scene would you like me to load? And you say I would like to load the current scene. Okay, so we've seen this thousands of times in games where if our health gets too low, we reload the level. Okay, so if we have our enemies and they are tagged as enemy, and then I push play, come over here, take some damage. Probably should have set my health to be a lower value. Yeah, I'm just gonna set the health to be, actually I didn't attach the script. Player health, there we go, set the health to 2. So if I get hit twice, then I will reload the level, or I should reload the level. There it goes. All right, nice, perfect. So the last thing that I want to show you is the easiest way to make it so that you have multiple enemies, and that's by using what's called the prefab system. So we can select any object like our enemies in here, and we can just drag it down into the assets folder like this. You see I've already done this before. I have another enemy right here, and this makes a blueprint of our enemy. So then we can drag it from the project folder out into the scene like this, and I can make a bunch of different enemies. And in fact, these ones I can say you 3 I want to paste not in the X direction, but I want you to paste in the Y direction. I'm going to up my player's health because I'm not good at my own game and I don't want to die before I get there. So there we go. And we see that they're pacing in the Y direction. They're pacing up and down that way, which is pretty nice. You think about the fireball enemies that are in Mario. You know, they come out of the lava and they go back down, or the flying shell enemies, right? Nice. We can also see if we really want to, we can select them and we can have them go in both directions. So I did X and Y, and it will normalize that. If I look at them, then they should be moving in the diagonal direction. Okay, so you can mess around with setting different values for the pace direction, and as long as all of our enemies are tagged as enemy, then they'll deal damage to us. On top of that, we can also create something down here that's like a different tile map. It's like a death tile map. If we run into that tile map, then we die, right? So we could come into our don't think so. Okay, we could come in here and we could have something else that says if collision game object tag equals death, HP equals 0, or just reload the scene. We can just reload and copy this line of code and reload the scene. So that is all for this week. Next week we are going to be working on bringing animations into our level, as well as loading like a windscreen and building the game and that sort of thing. So if you do want to prepare for that, you can create a character sprite sheet, so walking animations, jumping, idle, that sort of thing, and then we will see how to do that and then actually get to build our game and be done. So thanks for watching the video. I will talk to you next week.